Okay, so here's a couple of questions that were asked about using the quadratic formula. And this is problem 1.4.65. They ask us to solve x squared plus 10x plus 4 equal to 0. And so if we're going to use the quadratic formula, we need to identify a, b, and c. And a is the coefficient of x, so a here is 1. B is 10, coefficient, I think I said a is the coefficient of x squared, so that's a 1. B is the coefficient of x, that's 10. And c is the constant, which is 4. Okay, and our formula for the quadratic is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so everywhere I see an a in the formula, I'm going to plug in 1. Everywhere I see a b, I'm going to plug in 10, and then c, I'm going to plug in 4. So it's going to look like this. Negative 10, plugging 10 in for b, plus or minus the square root of b squared, so that's 10 squared, minus 4 times my a is 1 and my c is 4, and this is all over 2 times 1. Okay, and now what we need to do is we need to simplify. So this is negative 10 plus or minus the square root of 10 squared is 100, and then I have 4 times 4 here is 16. Okay, and this is all over 2. And then I want to take and simplify on the inside of my radical. 100 minus 16 is 84. And I need to simplify this radical, and simplifying radicals, what we want to do is we want to see if we can find perfect squares that exist on the inside of 84. So, 84 is going to be divisible by 4. I just want to see if it's divisible by something like 16, and it's not. So I could rewrite this as square root of 84 as 4 times 21 all over 2. So 4 times 21 is the same thing as 84. And the reason that I'm writing it this way is that I know that the square root of 4 is going to be equivalent to 2, because that is, just to write it out for you, that is the square root of 2 squared. And whenever I get my exponent and my index to match, there's an assumed 2 here. There's an assumed 2 right here in the index. Whenever I get that index and the exponent to match, then whatever this is going to come out of my radical. Okay, so this is how we simplify radicals. So negative 10 plus or minus, take out the 2, so we're left with 2 square root of 21 over 2. Now, this actually will simplify further because this 2 will divide into both the negative 10 and this 2 right here. You can't take the 2 on the inside of a radical, but the coefficient on the outside you can divide into it. So if I take this and break it up, it's negative 10 over 2 plus or minus 2 root 21 over 2, and negative 10 over 2 is negative 5, and then we have plus or minus, these 2's cancel here, and the square root of 21. So your answer here would be negative 5 plus or minus the square root of 21. Okay, and then also a very similar question was asked for 1.4.69, and they again ask us to solve, and we have 3x squared minus 7x equals 5. And when you're using the quadratic formula, you always want to set your equation equal to 0. So I'm going to bring that 5 over by subtraction, set it equal to 0, and then again I'm identifying my a, b, and c. And then I'm just going to stick these into the formula and simplify. So this is going to be x is, it's negative b, so it's the opposite of a negative 7 here, because b is actually negative. We have plus or minus the square root of b squared, so negative 7 squared, minus 4 times a is 3, and c is negative 5, and this is all over 2 times 3. Okay, so x here is 7. This is plus or minus the square root of 49. Negative 7 squared is 49. And then I've got a negative here and a negative here, so this is going to become positive. And then 4 times 3 times 5, so that's 12 times 5, which is 60. And that's all over 6. Okay, So I want to simplify on the inside of the radical. So this is going to be 109, and then all over 6. And we need to check and see if there's any perfect squares in the inside of 109, or that are a product with 109. So I don't really see any. Just making sure I didn't make any mistakes, because I am expecting this to simplify. 4 times A times C. Nope. Yep, so I don't see it simplifying. So this would be your answer right here. What I'm doing is I'm looking for, perfect squares that would multiply, that are factors of 109. And I'm trying 4, I'm trying 9, none of those things are perfect squares there. Well, 4 and 9 are perfect squares, but they're not factors of 109. So it's not going to simplify. So that would be your answer there.